can we draw in these two normal distribution curves? Okay, I want to use a diagram. We draw out together and we recap on the different phrases you have for the chapter. First one is for X bar, second one is for Z. Help me to draw in a normal distribution curve before we proceed with the solutions or with the descriptions. Assuming that we have a left tail test, let's start with what is the meaning of significance level. Significance level will always have this marker here, and then you want to get the area. This area here is called a significance level. They are referring to an area on the graph. So sometimes in the problem, you want to calculate this value on the axis with respect to significance level. What is the name of this point called? This is called the critical value. Critical value is the value on the axis with respect to significance level. So what will be the name of this segment towards the left of this critical value? The shaded region based on the X bar values is also called the critical region. So when the question asks for critical region, they are looking for a range of X bar values that will give rise to this segment over here. So what do we take to compare with significance level? We always go for this thing called p-value. P-value is also another area. We take an area to compare with another area. So p-value is always compared against significance level. We are always checking if this is larger or smaller to determine if you will reject H0. And what is this line here with respect to p-value? This is your X bar, the sample mean. P-value is always the area with respect to X bar. So for your rejection of H0 is always that significance level region. You reject H0 if p-value smaller than significance level. So for the exact same thing, we can always standardize to give you this thing called the test statistic. Test statistic distribution is referring to Z, and Z is given by X bar minus mu divided by your SD, which will look like this. What are the differences when you switch from an X bar curve into a Z curve? Areas all stay the same. So you are going to get the same marker here that will give rise to the same area. Significance level doesn't change. So if initially the significance level is 5%, on your Z curve, this will still be 5%. But the value on the axis will change names. This is now a Z curve. This is called the critical Z value. Or sometimes we call it Z critical. Both means the same thing. It's for Z curve. So p-value concept, again, areas don't change. So let's say the initial p-value was 0.03. It will stay the same area as 0.03. But this on that axis is no longer X bar. It's not X bar because it's a Z curve. So this value on the axis is called the Z calculated value, or some of your schools call it the Z value. Both mean the same thing. These are the standardized sample mean. So you take the sample mean, you minus mu divided by SD, you get the Z value. Okay, so it's the values on the axis that will change numbers when you change to Z. Areas will stay the same. So let me go through then with this table here, just to illustrate how to reject H0. Let's say everything is done at 5% significance level. If you have a left tail test, your rejection region will be on the left-hand side. If you want to find the number on the axis, it will be through inverse norm. So we inverse norm 5% with left. Reject H naught will mean that your Z value must be inside this rejection region or this critical region. When should you apply p-value? When should you go for Z-value? P-values should be applied when all your four things are known. What are the four values? Your X bar, mu, sigma, n. If all four are known, I would go for p-value unless the question says otherwise. Okay, so Z-value will be for problem types where one of them is unknown. Any one of those four is unknown, you go for Z value so that you can find the range. Default is by p-value, and the rationale is because p-value always sticks to the same sign. Regardless of what test, left, right, or two-tail, p-value signs don't change for reject H naught. Okay, it's Z value that may switch signs because of the different directions. So if it's a right tail test on the second row, rejection region is on the right-hand side. You inverse norm right with 0.05 to get that value. Rejection, same thing, Z value inside that shaded region. Okay, so you want Z more than this number. Last one is the special case. Remember, if it's two-tail, your 5% will be split into two sides. You get 2.5 on each side. This inverse norm, please be very careful. It's 0.95 in the center. This is the only one that you key the complement. You don't key 5%, you key the complement center. So this time, rejection will take two values or two sides. Your Z value is either in the left or in the right side. So there will be an OR involved if you're using Z value to test.